Let's consider this circle theorem, right? So this is our next topic. Our next topic is circle theorem. Okay. Now today we are going to treat on angle in a semicircle. Okay. Angle in a semicircle is a right angle. What do I mean by that? See, this is if I mark this as x and mark this as y and mark this as the center, which is 0, do you know that if I draw from this circumference to the center of the circle is called radius, and if I draw from here to this place, the whole of this is called a diameter. And a diameter is when you add this radius plus this radius, you are having a full length of a diameter. So I say that the angle in a semicircle is a right angle. Angle in a semicircle. Now, if I draw something like this, from here to this place, okay, is called a sector. Alright? I call this a sector. I draw from here to this entrance. Now, this is two sectors crossing diameter. Alright? And this is angle in a semicircle is a right angle. Okay, so if I draw a line from here to this place and draw a line from here to this place, and I draw a line from x to y, dividing the circle into two semicircle, right? And this is a 0, which is the center. Now I can say that angle in a semicircle is right angle, and so this is a right angle. This is a right angle, right? So angle in a semicircle is a right angle. Angle in a semicircle is a right angle. Now let's prove this theorem here. I can call this x. Okay, let me call this x, y, z. Okay, this is z. Okay, so let's prove this theorem. Given that xy, or let me say xz, is a diameter, right? Xz is a diameter of a center okay. Now center 0 and y is any point. Y can be any point. I can decide to place my y here, and I will draw it like this. I can decide to place my y anywhere. I can place my y. So given xy or xz, that is xz, is a diameter of a center, and center 0 and y is any point. It can be any point. Okay, I can decide to draw my y here, but I can decide to put my 0 here. Okay, so let's prove center O and y is any point on the circumference. Okay, on the circumference. This is circumference. On a circumference. Okay, when I talk about circumference, I'm talking about this line drawn here, right? This is the circumference of a circle. Now we are going to prove that. We are going to prove that angle xyz is equal to 90. Yes, we are going to prove that angle xyz is equal to 90. Because remember that I told you that this theorem is called angle in a semicircle is a right angle. So since right angle triangle is always 90 degrees, okay, right angle triangle is always right angle, not right angle triangle. Right angle is always 90 degrees. So we are going to prove that angle xyz is 90, because this theorem states that angle in a semicircle is right angle, and we are going to prove that angle XYZ is 90. That is where we are going to accept that angle in a semicircle is a right angle. Okay, let's go. Let's try. Now, do you know that angle XOZ is equal to 180? 180. That is, you prove. That is straight line. That is, angle in the straight line is 180. Accepted. Angle in the straight line is 180. Because any line drawn from here to this place, the angle here is 180 degrees. Because angle in the straight line is 180 degrees. Right? Now, do you know that angle XOZ is equal to the 2 times of angle in the circumference? That is angle XYZ. That is angle in the circumference. Angle in a, okay, that is angle at the center. Sorry, angle at the center. Angle at center. Angle at center is twice. Angle at circumference. This is circumference. This is circumference. Okay, angle at the center is twice the angle at the circumference. Right? So this is angle at the center. That is angle XOZ. Okay, is the center angle. Is equal to 2 times of angle in the circumference. The circumference of a circle is this, and the circumference here is XYZ. Is the circumference. Why? The center angle is XOZ. So the circumference angle here is angle XYZ, and we are considering this angle here. Yes, we are considering that angle here, right? And we also consider this angle, the center angle. Okay, so the center angle is XOZ. Okay, is 2 times the angle at the circumference. That is angle XYZ. I call this Z or Z rather. Okay, so therefore, let's continue it here because of space. We can say that therefore at 180 degrees is equal to 2 times of angle at the circumference, right? That is angle XYZ. Remember that angle XOZ is 180. Is that right? Look at here now. Angle XOZ is this, but angle XOZ is 180 degrees. So we can replace this with 180. We substitute 180 into this because this is equal to this, and it's possible we do that. Right? So we can say that 180 is equal to this angle. That is 180 degrees is equal to this angle. Right? So to find this angle, what are we going to do? To find this angle, remember we have to prove that angle XYZ is 90. Now to find this angle, which is the angle we are looking for, to prove that this is equal to 90, you have to divide both sides by 2. So you divide this side by 2. This is cancelled out, and the angle is now proved that angle XYZ is equal to 180 divided by 2 will give you 90. You now see that we have proved that the angle here is equal to 90 degrees. And remember, this theorem is called angle in a semicircle is right angle. You can see the angle in a semicircle here, okay, semicircle XYZ is a semicircle, because if I clean this, we have a semicircle. So angle at the angle in a semicircle is right angle, and the right angle is always 90 degrees. And you can see that this is angle XYZ is 90 degrees, and it is proven that angle in a semicircle is a right angle. So in my next video, I'm going to send you some questions. This is just the introduction part of circle theorem, and the first theorem here is angle in a semicircle is a right angle. That is the end of the introduction to this video. In my next video, I'm going to send you problems on angle in a semicircle is a right angle. Thank you for watching this video. Stay connected for more. Thank you.